exciting news is the discovery of water stored inside glass beads formed by violent collisions of space rocks with the surface of the Moon. According to the study published in the Nature Geoscience journal, the amount of water stored in the beads is estimated to be around 270 trillion kilograms. The presence of water on the Moon is no news to us. If we trace back the history of water discovery on the Moon, NASA's lunar orbiters already found evidence of water inside the Moon's permanently shadowed polar craters in the 1990s. In the 2000s, a reanalysis of samples from the manned Apollo missions of the late 1960s and 1970s detected hydrogen in the lunar soil. And the recently retired infrared telescope SOFIA confirmed in 2020 that water is present on the Moon, even outside the dark craters. The origin of this lunar water is, however, still somewhat unclear. Fortunately, there might be an answer now. Glass beads were collected and studied during China's robotic Chang'e 5 mission in December 2020. The Moon, unlike Earth, has no protection of the atmosphere. When it is bombarded by tiny meteorites, the heat generated by the impact melts the surrounding surface material, which finally cools into the glass beads. Water is made up of 2 hydrogen atoms and 1 oxygen atom. The beads act like sponges which store water. The solar wind is a flow of charged particles emitted from the Sun's atmosphere across the solar system. The hydrogen required to make water molecules comes from the solar winds, while oxygen, on the other hand, makes up nearly half of the Moon and is trapped inside rocks and minerals. According to research, mild heat of around 100 degrees Celsius is enough to extract water from the beads. The researchers said that a sustainable water cycle on the Moon might exist due to the interaction of the solar winds with the lunar surface. Knowing how water is produced, stored, and replenished near the lunar surface would be very useful for future explorers to extract and utilize it for exploration purposes. The glass beads may serve as a convenient resource for water extraction to produce rocket fuel on the surface of the Moon for missions to more distant destinations.